Right, in the last one we looked at these 4 metals reacting with just cold tap water. We're now using 2 molar hydrochloric acid with the same metals. Let's see what happens. Now, previously one of them reacted. Iron would have reacted if we'd given it enough time, but for the purposes of what we're looking at, we'll say it didn't react. It certainly wasn't quick enough. Calcium had reacted. Now, if a reaction is just a rearrangement of the atoms, if we had calcium added to water, which is obviously H2O, it released a gas. What do you think that gas was? It was hydrogen. What happened was the calcium reacted with the water molecule. It ripped off a hydrogen, which was released as a gas, and became calcium hydroxide, or CaOH, and then plus H, which was the gas being released. Okay. Now, calcium clearly reacted with water. I guess you can have an idea what might happen with hydrochloric acid. We're going to have a look at what happens with these other metals as well, and then we're going to actually try and trap the gas to see if we can prove what gas it is. It might be a bit difficult in calcium's case because calcium is very reactive and the gas might overload the boiling tube. Please note we're now using boiling tubes because I've had to, we only have one size bung in the labs at the moment to capture gas. So, first up, iron and hydrochloric acid. In it goes. I'll put the bung in, and then let's have a look. So, telltale sign the reaction is happening. Well, gas is definitely being given off. Remember that it might have been slow to react with the water, but actually in this case a fairly vigorous reaction has already started happening. Right, calcium and hydrochloric acid. I'm going to use a lot less compared to last time. Now if I pull back, we may see the bung pop off at some point. Which is up there. If you hear a popping bung, that will be that going off. Let's have a look. Well, it's certainly a more vigorous reaction than the iron, so that will help us when we come to rank it. Copper and hydrochloric acid. Let's have a look. Put the bung in just in case. Is the reaction happening? No. Nothing's happening, no gas being given off. You can see the difference between it and calcium. Calcium is roaring away. Right, finally then, magnesium. And it would appear to almost be more reactive than calcium. That I think is a little bit more about how I put it in, and unfortunately this experiment is not quite fair because the calcium is not in a powder whereas the magnesium is. So please bear that in mind. However, after the initial reaction you can see that calcium is still frothing away compared to the magnesium. That initial reaction was more due to the fact that the magnesium is powder form and not granular form. We can see then that, well, iron still reacting, calcium definitely reacting, copper no, and magnesium is reacting. Let's test then to see if we can confirm what the gas is. First off, what test do you think we might be using? And also related to that, well, what reaction is happening? We know a reaction is happening, we know the atoms are being rearranged. In the case of iron and hydrochloric acid, I want you to think about what the word equation or formula equation is for that. A reaction has happened. So we're going to see if we can prove what gas it is. You have to bear with me because I've only got, it's just me. So I'll try my best. The answer to what kind of test it is the squeaky pop test. Try and give it enough room so you can see it. Right. Oh, just heard it. Did just work, but not a very vigorous one. Okay, partly due to me and to not having a partner to help. Right, calcium. I can tell you that the boiling tube is very warm. I'll try and get it in shot. Bigger reaction there. Squeaky pop test confirms for what gas? Hydrogen. Copper. Well, there's no point me even testing that because there's no gas being given off. Magnesium. Also confirmed as hydrogen as well. Okay. Right. There you go. That is the reactions with acid.